Hello and good day, folks. Sorry I didn't turn up my volume, so we didn't hear the beep, 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 but we are live and we are going. Moving on to CO17. Folks, moving on to CO17, which is using relations, which we defined that yesterday. A relation is what? Nope. A collection of ordered pairs, which we talked about could be looked at as a graph, a segment line, or as a function table. So we're now using those to determine if an equation is a function. So the new word today is function, which you've used before because you've made function tables. That's what Mrs. Feynman called them, I've been told, function tables. But what is a function? Warning for you, sir. What is a function? Crinkle.
A function is like a job or like a work or something that they do and like their use.
We are looking at it in a mathematical sense. Okay, so a person's function might be their purpose or what they're being paid to do or whatever. But in the mathematical sense, particularly the graphing sense, anyone know what a function is? Yeah, Kylie. Okay, there's something called function notation, which we'll talk about actually tomorrow. That kind of goes more along line with that. But at its base, a function is a relation, right? So it's a table, segment, or line, or any collection of ordered pairs. There are others, but we're going to focus on those three right now. It's a relation where every x value has exactly one corresponding y value. Okay? It's a relation where every x value has exactly one corresponding y value. I've got two ways to explain that once we're done with the definition here. Those of you who are finished writing this down, take a look at these tables down here. Take a look at the two that I have labeled a function and the two that I've labeled not a function, and then reread the definition and tell me what in the world I'm talking about. How do these two tables show every x value having exactly one corresponding y value? And then the two tables on the right, the not a function tables, how do they not show that? How in the world does this definition fit what we have here? Alex? What? Why is your hand up? Oh. Stretching with one hand right after teacher asks a question. Yeah, great timing. Arlene.
The one without a function, it has one that equals other different numbers.
Sure, yeah. So let's take a look at the not a function tables first. Our x value of 1 here has three different corresponding y values associated with it, right? When x is 1, y is 6, and then it's also 10, and it's also -9, okay? For this table here, the x value of 1 has three corresponding y values. I don't know what to do. Are you stretching? Are you, Alex? Oh.
What about in the function it has 8 and 9?
Ah, good question. So this function table is here. I mean, first of all, let's talk about, before we get to that, let's look at the other not a function table. Which x value has more than one corresponding y value, Jack?
-2.
-2 has more than one corresponding y. -2 is 7, and -2 is 10. That's a problem. It just means it's not a function. Looking at our function tables here, notice the x values in both tables, they're all what?
Different.
They're all different, okay? In the first one, when x is 2, y is 9, one corresponding y. When x is 5, y is 7. When x is 8, y is 10. When x is 4, y is 18. Okay? In the second one, when x is 1, y is 6. When x is 8, y is 10. When x is 9, y is 10. When x is 12, y is 15. Alice is asking about this part here. Okay? Does that still fit the definition of a function where every x value has exactly one corresponding y? Yes. Okay? In order for something to be a function, basically x cannot repeat. Y can, because these y values are corresponding to different x's. Okay? That's the difference there. X cannot repeat, whereas y can. If x repeats, it's not a function, as we see in the two tables on the right. If x does not repeat itself, it is a function, as we see in the two tables on the left. Long John.
Okay, so say there's like a 5 in the x and then another 5 in the y, but they were like connected to each other, so it's like 5 and a 5.
Like they were, if we had a 5 here and a 5 here, that would be okay. It just means that 5 is the corresponding y value to the x value 5. Okay. If I added a 5 here, then what would that make this table on the left here? Not a function anymore, right? Because it already has a 5. If I added another 5, then that would be a problem. But I'm not going to do that, so it's still a function. Max.
So it still wouldn't work like if you added a 5, but then it still equals 7.
If I repeated the ordered pair 5, 7, it would still be a function because 7 is still the one corresponding y value to x. I mean, I don't know why you would repeat something, but if you did, it would still be a function. Jack.
So I'm just taking a look at the ones on the bottom.
Yeah, let's not do that yet, though. Okay. Any other questions on what we've talked about so far? Okay, because my other way to explain it is using birthdays. Okay. To explain a function, one can relate it to birthdays. Here's the question. Can two different people have a birthday on the same day? Yes. That's kind of like what Alex was talking about here with this 8 and 9 both equaling 10. 8 and 9 represent two different people that have a birthday on the same day. That's okay, right? That can happen. However, can one person have a birthday on two different days? Surely not, right? That's what we're saying here. -2 being one person has a birthday on 7 and 10. No, doesn't work like that, right? So if you think about it either in terms of birthdays or x repeating itself mathematically, the result is the same, function versus not a function. Are you going to argue with me about a person having? Okay. Every year someone does, and I figured you might be the one. But yeah, go ahead.
So on how it's like -2 and
What a catch.
what a catch. Bravo.
Sorry.
So I guess it's kind of arguing, but there's two -2s.
Yeah.
But they're on different heights, so they wouldn't be. So why can't that be both on the same thing?
You mean their position in the table, they're separated from each other?
No.
What do you mean they're different heights?
It's hard to explain. So on the x, they're both the same. I'm like, why can't it be that? How is it not a function? Because it's on different heights.
I mean, because the y value is different? We'll talk about that when we talk about the vertical line test right here. So hold that thought. Okay, hold that thought. Long John. You're going to battle me on the one person, two birthdays. All right, go ahead.
So if you were born on leap day, and because of that, it doesn't happen every 4 years. So you move your birthday to the next day. So and then when it comes to leap year, then you have two birthdays because you moved it the day before.
No, you still have one birthday. You're just celebrating it on a different day. I mean, your birthday is still the day on which you were born. Half birthdays, they're only celebrated so people with summer birthdays can bring in treats during the school year. That's the only reason why. Still not a birthday. It's a half birthday. I mean, Crinkle. Jack, sit flat, please. Folks, shh. Alex, sit flat, please. William, stand for the rest of class.
On like 11:59 and 12, and they explain, so they say that your birthday.
What do you mean they can't explain? If they can't explain what time you're born, you need a better doctor.
No, like if it was like seconds away from midnight.
Yep, so that would be 11:59. Gotcha.
But then, like, but it was still on the thing, so like they couldn't
On the thing?
explain. It
It
was such a close, like, it was like if it was close. What? It was closer to what you're either
Yes. 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 All right, last one. Then we move on. Aiden. Jack. Crinkle, you've had your chance.
How about if in the future they invent like a time ray where you can go back in time to before
If that ever happens, Aiden, I'll just edit my binder sheet. That's fine. It'll be okay.
What if you travel to the other side of the world?
What was that?
3, 2, 1. You are quiet. Catherine, warning for you. I just counted down. Beckman. Wyatt, warning for you as well. We're not there yet. Claire.
So this is like really super quick.
Yep.
So in Chinese, like people, you have 2 birthdays, one on Chinese New Year and one on your actual birthday.
Okay.
That's
I'll have to research what you're actually saying to see if that makes sense against my statement. Max?
What if you like, so it's your birthday, but then you like immediately get on a plane where it's like night, so then the next day, then it's your birthday again.
No. Your birthday is still one day. It's still one day.
But it's 3 hours more. What if it's
Still one. You just made your birthday longer. That's all. It's just one day. Kylie, last one. Then we move on. Vincent, Jack, Long John.
I was just going to say that what Claire said was true because when we did that inside, we read Inside Our Own Back Again last year, and that it talked about that.
I didn't say it wasn't true. I said I'm just going to research, do my own research on the topic. That's all. Okay. Going back to Jack's question earlier, Will sit flat, please. Thank you. What Jack was asking is, what if you've got 2 like x values, but because they have different y values, they have different heights. Okay. So an example of that is what we see here in the second graph. The x value of, say, 2 has 2 corresponding y's, right? It looks like when x is 2, y is also, we'll call it about 3 just for purposes of estimation. And when x is 2, y is also about -2. Okay? So here's an example of one x value having 2 corresponding y's but are different heights. And he's asking, why would that still not be a function? Okay? When you're looking at a graph, there's something called the vertical line test. And what that says, when checking to see if a graph is a function, so not using a table, but using a graph, use the VLT. If you can draw a vertical line anywhere that touches the graph more than one time, it is not a function, such as we have here. If I put a vertical line through this graph, it hits the graph in 2 spots. Okay? That means that in a table, we would have this situation where we have 2 or the same x value corresponding to 2 different y's. So the fact that they're different heights, Jack, means they're going to cross it's going to cross the graph twice, meaning it's got those 2 different corresponding y's, and therefore it's not a function. Okay.
So how was that one I guess it's like straight?
This one? So any vertical line I put through this graph, how many times does it hit the graph? Yeah, just once. Okay, so the vertical line test, that word's important, vertical line test. Any vertical line, if it touches the graph only one time, it's a function. If there's anywhere in the graph where it touches twice, that means that one x has 2 corresponding y's, and it is not a function. Arlene.
Can't you just use the y line already instead of like drawing one?
You mean use the table?
No, using the graph, like you can just like use the y-axis instead of drawing a vertical line.
No, because you might have a situation where, let's see, your graph does something like this, so the y-axis only touches it once, but there is a place where I can put a vertical line and it'll touch it more than once, therefore it would not be a function. So, yeah.
So if you go to the second one, the one that's like a V almost, you look at it. Couldn't you put it all the way to the left to where there isn't any?
Right here?
No, the other one.
This one?
Yeah.
Yeah. If I draw my vertical line right through that very lefternmost point, it does only touch it once. But again, it says if you can draw a vertical line anywhere that touches the graph more than once, it's not a function. Okay, so anywhere, it's not a function. Jack.
Alright, so the last one, I'm confused by how on the end of it.
Yeah, the last one's a little bit tricky in the sense, does this actually go vertical or does it continue to kind of curve outward? Your binder sheet probably didn't copy off very dark. It usually doesn't, but maybe you can see better here. It's not quite going straight vertical. You can kind of tell because how the pixels are there. So I would call that a function. However, if you said it was not a function because it looks like it goes vertical, I wouldn't dock you points because you're understanding the difference between the two. Okay, Kylie.
So if it's vertical, if it would have been vertical, it would be
Not a function.
not a function?
Correct. Why? Because a vertical line, let's just use this vertical line here that I've got drawn here. Okay, if this was our graph here, this ordered pair, we might, let's call this x value 3. Here's a y value of, say, 7. So when x is 3, y is 7, right? Since it's a vertical line, if I put a point here at, say, 4, when x is 3, y is also 4. Or when x is 3, y is also 1. When x is 3, y is also -5, right? A vertical line has the same value for x the whole way down, but y is changed constantly. Okay? Long John.
And the first one, nice trick. And the second row, are you counting because it hits the line twice?
In this V-shaped graph?
Yeah, because it hits the V and then it hits the x-axis.
I mean, like at this point?
Yeah.
Well, at that point, if I put a vertical line right through there, it still only touches the graph once. Okay? There's no spot where it like curls back on itself or overlaps on itself that would make it not a function. Okay? The last question, I think this is one Beckman had a question on earlier. It says the ordered pairs of a function are 4, 3, -2, 1, 3, 6, and 0, -5. What is an ordered pair that could be added to make the relation not a function? So currently, it is a function. What could we add to make it not a function? I'll let you answer that on your own. All right. This is homework for tomorrow. Are there any other questions, comments, concerns, complaints, comments, congratulations, criticisms?
Congrats on teaching us.
Thank you.
All right. That's how you math, folks.
Don't